Hello students, welcome to the class again. In the last class we had a discussion about versatility of carbon and we got to know that the versatility, and because of that carbon has a tendency of forming chains and bonds, numerous amount of bonds, and along it they form chains. So students, we will discuss about now today in the class saturated and unsaturated hydrocarbons. Okay, and these saturated and unsaturated hydrocarbons are segregated into, first saturated hydrocarbons segregated into alkanes, and unsaturated hydrocarbons they segregate into alkenes and alkynes. So students, we will study all of them but step by step, so that we will be clear with it. I have a video so that I can show you and you can able to simplify what it is exactly. So let's watch it.
Have seen the amazing property of carbon to form so many bonds with a variety of other elements and even with other carbon atoms. Its capability to form so many bonds is what makes carbon widely present. However, the living world is dominated by one major combination. What do we mean by this? Well, although carbon forms numerous bonds with several elements, the most preferred element for combination is hydrogen. Yes, hydrogen and carbon readily form bonds to form a vast range of compounds. Any idea what the combination is called? These are collectively called as hydrocarbons. As the name says, they are compounds chiefly containing hydrogen and carbon. So are these compounds only made up of these two elements? Not necessarily. Hydrocarbons mainly have these two. However, the other elements like oxygen, nitrogen, sulfur, and many others also participate in the formation of hydrocarbons. But the backbone consists of carbon and hydrogen atoms. So a hydrocarbon will chiefly have carbon atoms bonded to each other and hydrogen atoms attached to them. They would appear somewhat like this. Wait a second. These are the saturated and unsaturated compounds of carbon, right? Absolutely. That is why they are referred to as the saturated hydrocarbons, those with a single covalent bond between all the carbon atoms. We can see that all these are single covalent bonds here, and the others are called as unsaturated hydrocarbons, that is, those having at least one double or triple covalent bonds between the carbon atoms. Here we can see one double covalent bond between two carbon atoms, hence unsaturated. Now, in order to simplify our understanding and to study these hydrocarbons in detail, we divide these into three major categories. These are called the alkanes, alkenes, and the alkynes. Let's understand each type in detail. The first one is alkanes. This family is that of saturated hydrocarbons. That means all the carbon atoms share a single covalent bond with each other. Now, can you tell me the maximum number of carbon atoms that can be present in alkanes? Well, we cannot estimate it because the carbon chains can be too long to count. So how do we study the higher alkanes? I mean the alkanes which have a very high number of carbon atoms. Well, in order to study the alkanes collectively, we have a formula to represent them. The formula for alkanes is CnH2n plus 2. In this, N will be the number of carbon atoms. So can we represent all the alkanes using this formula? Absolutely. Let's try it out. The simplest alkane that we know is methane. Can you tell me its molecular structure? Yes, it's somewhat like this. So here we have one carbon and four hydrogen atoms. Its formula is CH4. What will the value of N be here? N, as we know, is the number of carbon atoms. It'll be 1. Let's substitute the value of N in the formula. The formula is CnH2n plus 2. The number of carbon atoms present is N. It's 1. And what about the number of hydrogen atoms then? It's 2 times N plus 2. On solving it further, we get the answer as 4. It's the number of hydrogen atoms. So in methane, we have 1 carbon atom and 4 hydrogen atoms. Does that give us CH4? That's correct. That is the formula for methane. The formula worked fine for methane. This is how all the alkanes can be generally represented with a simple formula CnH2n plus 2. Now look at the formula. Do you notice something? To get the formula of an alkane, all we need is the value of N. So we can easily find out the chemical formula of the alkane when we know how many carbon atoms make up the chain. Let's try this out as well. We know that the alkane with 2 carbon atoms is ethane. 2 carbon atoms means the value of N in the formula will be 2. What about the number of hydrogen atoms? The number of hydrogen atoms is 2 times N plus 2. That'll be 2 times 2 plus 2. That is 6 hydrogen atoms. Thus, the chemical formula of ethane will be C2H6. This is how all alkanes can be represented. Now let us talk about the next category of hydrocarbons in the unsaturated type category. We will talk about alkenes in the next video.
We were discussing about hydrocarbon, saturated and unsaturated. Saturated are alkanes, unsaturated are alkenes and alkynes. Alkenes refer to double bonds, alkynes refer to triple bonds. And alkanes, for the formula is CnH2n plus 2. We will understand about family of carbon compounds. Students, they have specific names. Like if we talk about methane, methane means meth means 1 carbon atom. Eth means 2 carbon atoms. 2 carbon atoms. Prop means 3. But means 4 carbon atoms. 5 means pent means 5 carbon atoms. Hex means 6. So on, hept, oct, non and dac. So students, as I have already drawn this diagram for you, see it is a diagram of methane which I have already been shown you in the video. It was like this, that carbon, we have 4 valence electrons and all of them will share one electron with hydrogen to form a bond and they will form methane. So students, you have to draw this electron dot diagram for at least till pentane. Okay, and one more example I have for you, that is of butane. Okay, butane means N is equal to 4, means the number of N will be 4. So if you will add and multiply with this number, you will get C4H10. So you will see I have drawn the diagram of butane. Okay, that contains 4 carbon atom and 10 hydrogen atom. You have to draw the electron dot structure of the same till pent. You have to complete it. This is your homework. Okay, take care and bye bye.